Okay, so this will be a result of rotating this about the x-axis, where the radius here will be r. Now it says from here, right, to there is h, right? That means from there to there will be h. So this is a coordinate. So from if this distance here is h, do you see that this location will be r minus h, right? This location will be r minus h. Does that make sense to you guys? Right? That'll be r minus h. So it's this area, this right here, that you're going to be rotating about the x-axis. Okay, you know that the equation of this circle is this. Okay, so it's going to be pi radius is a function of x squared dx. We're going to be integrating from r minus h to r. Let me write that as a big R. I don't want to confuse it with this r. So okay, if you want to know what this should be, think about, so these are always generated by a thin cylindrical, like a flat, right? A cross section. So let's say that's a typical radius right there. Let's say this is a typical radius. Okay, you're gonna spin this around like this. Okay, so do you see that? There's a little thinness. The thickness right here will be dx, right? This is the radius I'm talking about. Okay, we're gonna be adding like infinite thin these ones from when the x value is located from here all the way to r. So what's r then? R is equivalent to this y, right? So y squared is equal to r squared minus x squared. So y is equal to root of, right? So this is equal to r as a function of x. Let's replace it to our equation. Leave the pi out. Now because of the square root, then we're going to square it. We're just going to end up with this r squared minus x squared. True? Okay. The antiderivative of this will be r squared x minus x cubed over 3. Okay, so just plug it in now. You get r cubed minus r cubed over 3. You get r minus h squared, r squared times by r minus h, and then r minus h cubed over 3. Right, combine these two and you get 2 over 3 r cubed. Okay, and then here we're gonna get r cubed minus r squared h. Okay, and here we have, okay, that's kind of a mess. Let's combine these two first. So this is, I don't want to expand this. If I could factor it, I'm gonna factor it because it's long, right? So if I combine those two, I actually get minus 1 over 3 r cubed. Okay, minus, here you expand, you get r squared h, expand, you get plus r minus h cubed over 3. Okay, now let me just line it up like this. Let me put these beside each other like this. R minus h over 3 cube minus 1 over 3 r cubed, and put this at the back. So why am I doing that? What am I seeing here? I see something, that's why I'm doing this. Well, this is all over 3 now, right? You can see all over 3, and this is the differences of cubes, right? So this I can factor instead of expanding. So I can say r minus h minus r. Okay, and then square that, r minus h squared, right? Plus r minus h times by r plus r squared. Okay, make sense? All right, that r cancels out. Now let's clean up. Okay, what do we get inside here? R squared minus 2RH plus H squared plus R squared minus HR plus R squared. There's still quite a bit of expansion. I'm gonna factor out this third too, so you get pi over 3. That's gonna become 3R squared H. Okay, before I open this bracket inside, I'm gonna collect what's same. So those three are same. 3R squared. What else can we collect? That 3RH, and then just the plus H squared. Okay. Wow. All right. Okay, what can we collect here? We can collect these two actually. Oh, that's gone. Right, you can actually factor out H squared here, right? And you're left with 3R minus H. It's not bad. Okay, not as clean as 4 pi R cube divided by 3, right? But